Are there like tangent waves?
Yes, that's the next section. In the next section, we'll talk about graphing tangent and secant and cosecant and cotangent.
Have asymptotes?
They do have asymptotes. Yes, they do. Lots and lots of them. Asymptotes. Lines that get close to but don't touch.
Is it pronounced asymptote or asymptote?
I don't know. I say asymptote.
Asymptote.
Asymptote. I don't know. How I pronounce it doesn't really matter. They are really matters. All right, and then we found the other day. What if I gave you? I'll just call it y. Y equals 2 sine t. What does that 2 change? That 2 that I put right there. It changes the amplitude. And what does that mean? So instead of the maximum point being at 1, the maximum point is going to be at 2, and the minimum point is going to be at -2. Does it change the x values in any way, shape, or form? No, it only changes the heights. So it's going to really be the same picture, just kind of spread out. It's going to go twice as high and twice as low, but we're going to have the exact same x values that we had before. We're going to have 0, 0. This is pi over 2, 2. This is pi, 0. 3 pi over 2, -2. And 2 pi, 0. So putting a 2, multiplying by a number like that, changes the amplitude. Okay. What if I did this? Y equals 2 plus sine of t.
Oh, it will.
Say that again.
No, let's see.
You're absolutely correct. This is a translation. This moves the graph which way? Up, down, left, or right? Up. Adding a number outside like this moves the graph up and down. Since I'm adding 2, this is going to be an up 2. So again, it's going to be pretty much the same picture. The x values aren't going to change at all. What's going to change is the y values. So it will start at 0, 2. What's the high point going to be? It'll be pi over 2, 4. Why 4? I don't think 4 is the right answer. 3. It should only be 3. Why should it only be 3? Because normally sine has a high point of 1. We're moving it up 2, so the high point is going to be at 3 now. So this will be pi over 2, 3. Okay. Instead of pi, 0, what am I going to have? Pi, 2, because we shifted it up 2. So it comes back right here. Pi, 2. Now it's 1. Because 3 pi over 2, -1, if I go up 2, that's 3 pi over 2, 1. And then finally 2 pi, 2. So again, nothing changed any of the x numbers there. Simply changed the y numbers. The y numbers went up by 2. So if we multiply here, it changes the y numbers. You multiply the y numbers by whatever this is. Here I add to whatever the y numbers are.
So multiplying is the full length of black, and then adding is the translation.
Correct. Adding is a translation. Adding is what's called a rigid motion. Simply picks the graph and slides it up 2. Where multiplying by 2 isn't rigid, it's kind of like you grab both sides and you stretch them out. Oh, that's a wonderful question. The question was, will the x's always be 0, pi over 2, pi, 3 pi over 2, and 2 pi? And the answer is no. Because instead of shifting the graph up and down, I could also shift the graph left and right. So I could be mean, I suppose, and do something like a y equals sine of t minus pi over 4. It could be t minus 2 also. We will find they will typically have pi's in them, though. Could be t minus 2. All right, so how does this move the graph? Left and right. Left or right, which way? Right. Remember, left and right goes backward. If you have a minus here, it's going to move the graph right. So normally our sine graph starts at 0, 0. This one's not going to start at 0, 0. This one's going to start at pi over 4, comma 0, because it's not being shifted left, up, or down at all, is it? All right. So will I always use 0, pi over 2, pi? No, I won't, unfortunately. So that one starts right there at pi over 4, comma 0. Where's it going to end? Yep.
It's still 2 pi 9.
And how did you get 9 pi over 4? All right, so what she's saying is, normally we stop at 2 pi, but we got to shift it to the right pi over 4. So what she did in her head is she took 2 pi plus pi over 4. We're shifting to the right pi over 4. And she said this is 8 pi over 4 plus pi over 4 is 9 pi over 4. So it's going to end right there at 9 pi over 4, comma 0. Where's that point where it hits the axis again? How'd you get 5 pi over 4? Same trick, okay? Normally we end at pi. We're shifting to the right. So she took pi plus pi over 4, which gave her 5 pi over 4. Now I want you to notice something. Normally we start at 0 and we end at 2 pi. Where's the spot? Pi, which is exactly halfway in between, isn't it? So another way to answer this question would be, what's exactly halfway between pi over 4 and 9 pi over 4? Well, would you agree with me that the answer is going to have a pi over 4 since these both have pi over 4s in them? Yes. So really the question is, what's halfway between 1 and 9? 5. Halfway between 1 and 9 is 5. So this point right here is at 5 pi over 4, comma 0. All right, the high point normally is at pi over 2, which again is halfway between 0 and pi. So our high point's still going to be halfway in between. So what's halfway in between pi over 4 and 5 pi over 4? Again, the only numbers that really matter are the 1 and the 5. Halfway between 1 and 5 is 3. So the answer is going to be 3 pi over 4. It's always going to have a pi over 4 in it. So we're going to have 3 pi over 4, comma 1. And finally, halfway between 5 and 9. 7. So the low point is going to be at, well, it's still 7 pi over 4. The y number is the negative. So there's what that graph would look like. Exact same graph, pushed pi over 4 to the right.
So that bottom point is 7 over 4, right?
Yeah, this.
Okay, I just saw the 9 pi over 4 side.
No, that was just arithmetic to figure out that 9 pi over 4. Yeah.
Okay.
All right. So that's normally what I do. What I normally do is I find the beginning point and I find the end point. And then I go halfway in between, and then halfway in between, and halfway in between. All right, so let's try that again. How about y equals, we'll do a cosine, we haven't done too many cosines yet, of t plus pi over 6. What's that going to do? move it left. So cosine normally starts at 0, 1. Where's this one going to start? Negative pi over 6, comma 1. And it ends over here. Still at a height of 1. Where does it end? Normally it ends at 2 pi. So I would take 2 pi and I would subtract pi over 6 because we're shifting to the left. And you're right, you do the arithmetic, you get the common denominator, you add those up. That's 11 pi over 6. So that's 12 pi over 6 minus pi over 6. That's 11 pi over 6. Lots of practice with fractions in trigonometry. Always fractions. Okay. Now, again, I want to go halfway in between. Do you agree that the answer is going to have a pi over 6 in it when I go halfway in between? Yes. So all I really need to know is what's halfway between negative 1 and 11? 5, because negative 1 plus 11 is 10. 10 divided by 2 is 5. You add the numbers and divide by 2. So I'm going to have 5 pi over 6, negative 1. Okay, then my two intercepts. Again, they're going to be halfway in between. What's halfway between negative 1 and 5? 2 pi over 6. Okay, but normally we would reduce that fraction and we would write it as pi over 3. So this is going to be pi over 3 comma 0. And finally, halfway between 5 and 11. 8 pi over 6. And again, I would reduce that and write it as 8 over 6 reduces to be 4 over 3. So it's 4 pi over 3. Oops, 4 pi over 3, comma 0. Okay, so when you go to take a quiz or when you go to take a test, this is exactly what I'm going to want to see. I'm going to want to see one complete cycle drawn, and I'm going to want to see 5 key points marked. So here we have 1, 2, 3, 4, 5 key points. Here we have 1, 2, 3, 4, 5 key points. Questions on that?
You're like doing your equals, do you not have the comma 1 or comma 0? You just put like 1 over 6.
You can do it two ways. You can either label your axes and put a -1 there and a +1 there.
That's what I used to do.
That would be okay. Or you can label the points with the x's and the y's like I am. Either way is fine. All right, now what happens if I do something really crazy? What if I put a number inside there and I multiply? Y equals sine of 2t. What do you mean bigger and smaller? Pass.
Does it make it just go up to 7?
No. It changes the period. That's correct. It's going to change the period. So this one will not have a period of 2 pi. What will the period be? 4 pi is a good guess. 5 plus 2 pi is 4 pi. That's true. 6 pi? 4 pi squared? Can I borrow your calculator here? The easiest way to describe it is to look at graphs on the calculator. All right, so here's our graph of sine t. And then I'll graph sine 2 2t. So there's our traditional sine graph. It makes it less. So this sine of 2t, turn this one off for a second. So this goes through a cycle in about 1, 2, 3 units, a little bit more than 3. So the period isn't 2 pi, rather the period is just pi. So whatever this number is, it's going to divide the period. So this is going to have period. You always start with 2 pi, and then you divide by whatever that number is right there. So it squishes the graph this way. What if I put a 1/2 here? Then that would have a period of 4 pi. Because you would take 2 pi, divide it by 1/2, you would get 4 pi. Okay, so what that tells me is, where does my sine wave usually start? 0, 0. Is the start point of this one changing? No, because I'm not moving it left or right or up or down. So it still starts at 0, 0. Where does it end? Pi, 0. It's going to do one complete cycle in a period of pi. Okay, so where's this key point in the middle? Halfway between 0 and pi is pi over 2. So that's going to be pi over 2, 0. What's halfway between 0 and pi over 2? Pi over 4 is halfway in between 0 and pi over 2. So we're going to have pi over 4, 1. And then finally, halfway between pi over 2 and pi. Not pi over 6. 3 pi over 4. How'd you get that? Same way we did the other ones. So you add these together, and you would divide by 2. Now, again, do you agree the answer is going to have a pi in it? Yeah. So really all you have to do is deal with the numbers without the pi. So you've got a 1/2 and a 1. What's halfway between 1/2 and 1? 3/4, isn't it? Halfway between. So that's 3 pi over 4, 3/4 pi. So 3 pi over 4, -1. So that one cuts the period in half. All right, now I'm going to be really mean to you. Now we're going to go nuts. Y equals 4 sine 2 times t minus, I don't know, anybody got a good number?
4.
Pi over 4.
Yeah.
For this picture, for this graph, when I draw it, what's the amplitude going to be? 4, reluctantly. How do you know the amplitude is 4? Amplitude is always this number that comes out front. That's always the amplitude, that's 4. What's the period? Pi. How do you find the period? Whatever this number is right here, you take 2 pi and you divide it by that number. So it's always this number right here. You always divide by that number. That's pi. And then in trigonometry, the shift right or left is usually called the phase. So you hear it called the phase shift. So I'm just going to call it the phase. The phase shift is right by how much? Pi over 4. And that's because of this minus pi over 4 right here. So the phase shift is a right pi over 4. All right. So what's the first point I'm going to mark on this graph? Pi over 4 comma 0. That's right here. So I start with my phase shift. My phase shift told me I need to shift right pi over 4. Then I go to my period to find my ending point. My period is pi, so you're absolutely right. I'm going to take pi over 4 plus my period. So I take my starting point and I add my period, and I do the common denominator trick stuff, and you're absolutely right, I get 5 pi over 4. So that's where it's going to end. 5 pi over 4 comma 0. Then what? Middle. What's halfway between 1 pi over 4 and 5 pi over 4? 3 pi over 4, because halfway between 1 and 5 is 3. So right here, 3 pi over 4 comma 0. Okay. Alright, so this one's a little bit harder. What's halfway between pi over 4 and 3 pi over 4? 2 pi over 4, because halfway between 1 and 3 is 2. 2 pi over 4, though, we would normally write it as pi over 2. And what's my y value going to be? 4. Here's where the amplitude finally comes into play. So halfway 2, so 2 pi over 4 is pi over 2. Except it's going to go way up here, all the way up to 4. And again, I wrote this thing in the way, unfortunately. So you're going to ignore this in a minute. What's halfway between 3 pi over 4 and 5 pi over 4? 4 pi over 4, which is a fancy way of saying pi. So we're going to have pi negative 4 way down here. All right, so there's our graph. It has a big amplitude all the way up to 4, all the way down to negative 4, and there's the 5 key points. Questions on that? All right, let's do one more hard one with cosines in it. Y equals. Somebody give me a number you like.
7.
7. Negative 7. I'm going to go with negative just to be different. Cosine. How about we do a fraction this time? 4/3? 4/3 sounds hard.
1/2.
What'd you say, 2/3, Miller?
Yeah.
2/3? All right, we'll try 2/3. You guys are a little crazy. 2/3 t plus pi over 6.
Wait, so if it's negative 7, is it the origin would be pi, it would be negative pi over 6 and then 0. And this is the origin. That's the starting point. But it would go down first and then up.
Okay, so normally cosine starts at 0, 1. So this one, the first y value that I'm going to write is going to be negative 7. The first y value, it multiplies. We're multiplying here, so I think the 1 times the negative 7. If I wanted a negative 6, I would have a plus out here.
So it'd be negative pi over 6, negative 7.
All right, you need to be careful though, because notice last time when I wrote it, I had this number out front, and then I had this thing factored like so. So in order to find this phase shift, I really need it written this way. I need 2/3, and then I need a parenthesis, t minus or t plus something. So the first thing I'm going to do is I'm going to write this in the correct form. This should be negative 7 cosine. I need the 2/3 factored out. T, if I take 2/3 out of t, I get t plus. And now this is why you see 2/3 wasn't a good number. You guys made it hard on me. 2/3 times what will give me a pi over 6. Yeah, you're going to 2/3 times what will give me a pi over 6. So the question mark is going to be pi over 6 times 3/2. Flip and multiply.
I got point something.
Point something. Does it look like pi over 4?
No.
No? That's too bad because that's what I got. Hoping I'm right. Yeah, I am. Okay. I think so too. Okay, so sometimes they're not written in the correct form, and the first thing you have to do is factor that first number out to get it in the correct form to find your phase shift. Okay, so that's another little wrinkle that I can throw in there to make them even harder when I'm in that kind of mood. Okay, so now we answer our questions. What's the amplitude? Amplitude's always given as a positive number, so we would say the amplitude is 7. Always, always, always. How about the period? Not 2/3. Has something to do with 2/3 though. I take 2 pi and I divide it by whatever that number is. I take 2/3 of 2 pi and I divide it by 2/3. I'm going to flip and multiply. That's 2 pi times 3/2. It turns out okay. That's 3 pi. Period is 3 pi. And finally, how about my phase shift? Close. Negative pi over 4. It's shifting to the left, doesn't it? Negative pi over 4. Okay. Here's my graph. My first x value is going to be my phase, which is going to be minus pi over 4. What's my first y value going to be? Negative 7. Cosine usually starts at 1, but this time we're multiplying by a negative 7. So we're going to have negative pi over 4, negative 7. There's my first point. Okay, then I start with my phase, which was minus pi over 4. And I add my period, which is 3 pi, and that'll give me my ending spot. Now you can even see what I'm writing. So that's minus pi over 4 plus 12 pi over 4, which looks like 11 pi over 4. So my ending point is over here, 11 pi over 4, negative 7. Okay. Now we start playing our halvesies game. What's halfway between negative 1 and 11?
6
5. Negative 1 plus 11 is 10. You both added, that's right. Subtract. Negative 1 plus 11 is 10. 10 divided by 2 is 5. So it should be 5 pi over 4. What's the y number going to be? 7. Cosine is low on both ends and high in the middle. So we're going to have 5 pi over 4 comma 7. All right, finally we can find our two intercepts. What's halfway between negative 1 and positive 5? Halfway in between would be 2. So it's going to be 2 pi over 4, which is pi over 2, or 1/2 pi. You're giving me lots of right answers. So pi over 2 comma 0. And finally, halfway between 5 and 11. 8. So 8 over 4 is 2. So this is going to be 2 pi. 2 pi comma 0. All right, so cosine wave. Looks like that. Bless you. Questions?
Is that like going to be hard to do? Or make it worse?
I could make it worse.
No, you don't have to do that.
The only way I could make it worse, really, would be if I wanted to put like a +2 here, way outside, which would then shift everything up by 2 units.
That's it?
And then you
I could change the fractions and make it come out so the fractions don't come out so nice. I mean, the fact that our period turned out to be 3 pi was kind of nice. If I'd used that 4/3 like you wanted to at the beginning, then our period would have been a fraction, and we would have had fractions, and we'd have been buried in fractions. So, other questions?